Hello, this is a video presentation for paper ID 168 prepared for iSight's 2020 conference. So I'll be talking about on the effect of corrosion of copper electrode in Andrassy bentonite as grounding material. I've been given 7 minutes to do the presentation, so let's begin now. As for the background, electrical grounding, one of the most chronic obstacles to implementing an ideal and effective earthing system is the undesirable soil environment, such as shallow, rocky, highly acidic or alkaline soil, and dry upper soil layers are very common in earthing practices. The maximum grounding electrode resistance of a large electrical substation and commercial and industrial substation should be approximately 1 ohm and 1 to 5 ohm. In order to achieve this, alternative grounding material such as bentonite are often used to minimize the problem. In recent years, there are various studies have been reported on bentonite as grounding enhancement material, or GEM for short, in electrical earthing was found in the literature. According to Lim, bentonite is suitable backfill material to decreasing and maintaining the low grounding resistance of electrode for a long time due to its high water absorption and retention tendency. So what is bentonite? Bentonite is a naturally occurring clay mostly derived from volcanic formation. Mainly consists of a special montmorillonite minerals. So bentonite can be classified based on their major exchangeable cations. So we have sodium bentonite, calcium bentonite, or other or mixed type bentonite. So one of the main criteria of selecting a good gem is the electrical resistivity behavior of a certain material. So bentonite, having the unique properties, fulfill this criteria very well. Having a higher water retention promotes bridges for interconnecting particles and allowing electrical charges to pass through the gem and dissipate quickly. Now let's talk about grounding electrodes. So if you see from the picture, we have two types of electrode commonly used. One is the aluminum type, the other one is the copper type. One of the main problems is that high water retention from the ground enhancement material would inevitably induce corrosion of grounding rod connecting the gem to lightning terminals on high-rise structures. Reports have shown that the water content, pH, resistivity, redox potential, sulfates, and chlorides are the most common corrosion parameters of copper in electrical grounding. Apart from the recent study have shown that the presence of microbes may also contribute to corrosion process. So the resistivity is directly influenced by the change in the water content of the gem. The greater the water content, the greater is the risk for corrosion to occur. Corrosion makes the design life of a grounding electrode greatly shorten and reduce efficiency. It is also crucial to understand the type of microbe present in Andrassy bentonite used in this study that may also contribute to corroding copper electrode used for grounding purposes. Therefore, the objectives of this study are summarized below. The first one is to determine the type of potential microbe that may influence copper corrosion, and secondly, to investigate the degree of corrosion under different wetting conditions. In order to achieve that, a methodology was designed. So the first part A type of bentonite, which is known as Andrassy bentonite, collected from Sabah volcanic deposit in Tawau district, Malaysia, was used. The first step was to determine the geotechnical and microbial properties of this specific bentonite. Later, a corrosion test was performed by exposing a copper disc inserted into bentonite specimen and exposed to different relative humidity conditions using vapor equilibrium tests. Then the microstructural changes to the surface morphology of the copper disc before and after the test was determined. Lastly, the corrosion rate of each disc were measured. So these are the geotechnical properties of the bentonite used in this study. Then we identify the microbiological properties. Based on this, we identify there are a total of 8 types of microbes present in this specimen. So the effect of water content and corrosion rate, we identify that the higher the water content does not necessarily influence the corrosion rate. A bell-shaped curve was plotted, and it was noted that a relative humidity of 75.5 to 85% actually generates corrosion to the copper electrodes. At a very low relative humidity and at very low water content of bentonite, very low corrosion rate was found. So a bell-shaped curve was noted on the corrosion behavior of copper at different relative humidities. It was noted that the corrosion rate was found to be very low at high water content, higher than 85%. Surprisingly, the water content and resistivity of the bentonite do not influence the corrosion rate, as been explained in the literature. Higher water content, lower resistivity usually will cause corrosion to occur on copper electrodes. The bentonite also have a pore water pH of about 8.5, and the pore water in bentonite is somewhat alkaline, and this influences the corrosion rate, which caused the corrosion to go very slow. It is believed that the microbe have some influence on the corrosion behavior of copper in this study. When relativity is low, the water activity outside the microbe cell becomes low enough, it causes osmotic stress. Thus, the cell cannot take up water and becomes dormant. Thus, no corrosion activity was found. The case is also true when the water content is too much. These are the FESAM analysis showing the initial 0 day of the disk and after the test, which is after 66 days. Corrosion is a complex process that involves complex physical and chemical reaction. The presence of corrosion-induced microbes, such as identified in this study, consists of 1 species of bacteria and 3 species of fungus, may also contribute towards corrosion of copper rod. It was also found out that more water and lower resistivity values may not be a good indicator for investigating corrosion behavior of copper rod used for grounding application. For more information on the study, feel free to access the paper published. Thank you very much for your kind attention. Hope to see you in other session.